The next transformation is a stretch in the y direction, or a stretch parallel to the y-axis. It's sometimes called a scaling, and it may be called a scaling along the y-axis. The basic idea is that we have to multiply all of the y values by some constant. So we define this transformation as f of x maps onto a times f of x. We'll use as the example f of x is equal to x plus 3 multiplied by x minus 3. So under the transformation, it'll be a times x plus 3, x minus 3. When a is equal to 0, f of x will equal to 0 as well. So there's nothing to see. But as soon as we change this to, let's say, f of x is equal to 1 times x plus 3, x minus 3, you can see, as we would expect, the roots at negative 3 and positive 3 and an intercept of minus 9. As we increase this value, let's go all the way up to 5, we can see that we're increasing the amount by which the curve bends. We're changing the shape of the curve. But it's important to notice that the axis of symmetry isn't changing. It's the y-axis. It remains the axis of symmetry. And also the location of the two roots does not change. So we're changing how much the curve bends, but we're not changing the position of the roots. The larger and more positive the value of a, the more the curve bends. What if a is negative? Well, we'd get a reflection in the x-axis. So when a is equal to negative 1, we can see we have the roots again at minus 3 and positive 3, but the intercept is now at positive 9. And the curve is upside down compared to how it was before. It's now a hill shape. As we make a more negative, we increase the amount by which it bends downwards. Let's have a go at an example for ourselves. To summarize on what we saw in the animation, the vertical stretch can be written as f of x maps onto a times f of x. In other words, we're multiplying all of the y values by some constant a, which could be positive or negative. This changes the shape of the graph. The roots will be unchanged. They'll have the same location. And the axis of symmetry will be unchanged. So the x value of any vertex will remain unchanged. The y values will change though. The intercept in the original function of 0c would be transformed to 0ac. If a is less than 0, the transformed curve is a reflection of the original in the x-axis. Let's have a look at the example then. We're given the graph of some function f of x, and we want to sketch the graph of minus 2 f of x. Bearing in mind what we learned before, all we have to do is multiply the given y values by negative 2. The x values will stay exactly as they were before. Also, as we said, if the value is negative, in this case it's negative 2, the graph will be a reflection in the x-axis. So we'll have to use our imagination a little bit to figure out how this is going to go. We'll start then by taking each of the given points in turn. Minus 3, 6. Under the transformation, that will become minus 3, minus 12, which will be way down here somewhere. 0, 2
will become 0 minus 4. And lastly, the point 3 minus 2 will become 3, 4. So let's have a think about this. The vertex down here has now moved up to this location. And the vertex here has now moved over to here. And our intercept at 0, 2 is now over here. So we have to figure out what this graph is going to look like when it's flipped over, reflected in the x-axis. Well, this segment of the curve is going down towards the bottom left, so when it's reflected, it's going to come down from here to this point, which is now a minimum. It'll go up through the intercept and through this point here, which is now our maximum, and then back down like that. And that's it. Now have a go at the multiple choice question.